Hey there, physics students. Welcome back to another episode of Rapid Review for Honors Physics. Today the topic is acceleration. We're going to talk about what acceleration means and how to read graphs pertaining to acceleration. Acceleration can be defined as a vector quantity that's the change in velocity over change in time. That's the definition of acceleration. So if you look at a change in velocity, indicated here by v final minus v initial, divided by time, or more specifically, I would call that change in time. Normally, time starts from time zero. So if you see a t in an equation, usually it could mean a delta t. It could mean we started from time zero, and we're all assuming that. Back to the definition is a change in velocity divided by a change in time, and the instantaneous acceleration is what you would think. It's the acceleration at any particular moment, whereas the average acceleration, as shown in the equation, is more generally defined as the change in velocity over change in time over whatever period. A comment about the notation here at the bottom is that delta v could be represented as v minus v0 as well. So instead of saying final minus initial, I will probably just use v to represent the velocity at any time, and v0 to be the velocity at time zero. You might hear some people call that v naught. It's just a language thing. I think maybe more common in the UK. It means the same thing. It's the velocity at time zero, the initial velocity. They all mean the same thing. All right, now let's think about that. What does a change in velocity mean if we're driving a car? How would you change the velocity? Well, you could speed up. There's the gas pedal. You could slow down. There's the brakes. And here's the tricky one, right? Because velocity is a vector quantity. If you change the direction of a velocity, you're causing acceleration as well too, right? Because it's a delta v over a delta t. So if I'm turning, the steering wheel could cause me to have some acceleration. For now, for the rest of this presentation, I'm going to focus on motion in one dimension. It's a little easier to discuss, so my acceleration will be more about slowing down and speeding up. As we learned in the prior episode, we can look at the plus and minus sense of position and velocity and determine what's happening in real life, right? So I'm going to step over to the table here. I have a car set up on a number line. So here's my position description. And as we learned last time, if I move the car to here, I have a positive position. Right now I have a negative position. And if I'm moving forward, I have a positive velocity. If I'm moving backward, I have a negative velocity. That is the last time I'm going to use the words forward and backwards, because I think they're a little confusing. I'm going to do this again. I'm going to say my red dot has positive velocity and negative velocity. I say this because when I have the truck, right now, I have negative velocity. And somebody might say, oh, the truck's going forward. I just don't like it. It's just confusing. So we'll use a point represented by this red dot, and we'll talk about positive velocity and negative velocity. And I will avoid the words forward and backward. All right, so we're back to the slides now here. Acceleration, what does plus and minus mean for acceleration? Ooh, we got to figure that out. Let's talk about that in a minute. If we take the slope of a velocity time graph, what are the units? Oh, well, that's easy. It's change in that thing over change in that thing. So it's meters per second divided by seconds. Meters per second per second. Meters per second per second. Okay, so what would the slope of this be with units? Let me see, I'm going to do some math. It looks like it's 20, this is rise over run, right? 20 over 5, it's plus 4 meters per second per second. Meters per second per second. Now the units are weird, right? So meters per second, I could write in another way, just like meters per second. Or, this may not be immediately obvious, meters per second squared. We can convince ourselves that these are equivalent if we just go meters per second divided by seconds. And we know how, if we're dividing fractions, that all you have to do is multiply by reciprocals, right? So meters per second times inverse seconds. And if you do those multiplications out of the units, you get meters per second squared. So meters per second squared means meters per second, or meters per second. They all mean the same thing. Okay? Just get used to, when you see the units of meters per second squared, that those are units of acceleration. Those will be mostly what we use in this class. Others are legit. Like, I listed a few here, like miles per hour per second, or feet per second squared, or whatever. We'll use mostly meters per second squared in this class. All right, so let's look now at this slide here in this table about what an acceleration of 5 meters per second squared means. It just means that every 1 second, the velocity increases by 5. So if I had to make a data table, I would say at these different times, every time a second goes by, I get 5 more velocity units, right? 5 more meters per second. I'm going faster and faster. That's an acceleration of 5 meters per second squared. Likewise, minus 5 meters per second squared. 20, down to 15, down to 10, down to 5, down to 0. Now, I just hit 0. Does that cause any difficulty? Could it cause a difficulty? I don't know. Like, is that even possible? If you haven't thought about this before, you might as well, you could pause the video and think about it. If you have, you'll remember that there's no problem at all. Look at the table. It's okay to have 5 meters per second squared negative and just keep going past 0, right? Mathematically, total sense, right? 5 down to 0, down to -5, down to -10. Totally fine. It's totally fine. What this means is that during the first 4 seconds, the object is slowing down, right? Because I'm looking at the magnitude of the velocity. But from 4 to 6 seconds, the object is speeding up because the magnitude of the velocity is getting bigger, right? The magnitude of 10 is greater than the magnitude of 5, to pick 2 numbers there, right? So it's speeding up. That may not be intuitively obvious. I'm going to remind you that speed is just the magnitude part of velocity. Always good to remember. So for motion in 1 dimension, it turns out that position and velocity are what we discussed, and acceleration is, oh, what a mess. Acceleration is, if you get plus, it could mean 2 different things. It could mean that it's moving to the right and speeding up. It could also mean it's moving to the left and slowing down. And there are other combinations, right? If it's minus, it means something else. I'm going to read because I'm going to get mixed up, right? But it's moving to the right and slowing down, or moving to the left and speeding up. These are negative accelerations. So just because I have positive acceleration doesn't mean I'm speeding up. It's more complicated than we would have thought. Don't worry if that sounds confusing. We're going to get used to that. We're going to see this a lot. And we're just going to remember that if you see a plus or a minus with acceleration, you sort of have to know which way the thing's moving to tell whether it's speeding up or slowing down. If you want more practice, I would recommend, here's a link to the physics classroom. I'm going to post that link in the comment section or in the description of this video. As you're watching this on YouTube, you should be able to link to it, or you can read it off of this slide. It's good practice for understanding the meaning of what plus and minus mean in terms of acceleration. Really good practice. I recommend that you try it if you haven't already. And I think that's probably all we've got. That's all we have for today, and I invite you to join us again for our next topic in the Honors Physics Rapid Review series.